Hello everyone. So in this video we'll be seeing about cutting fluids. So what is the cutting fluid and why do we need that cutting fluid? So during machining process the tool will be in contact with the workpiece. So when we are giving some depth of cut and when we are moving it at a high speed, there will be lot of heat generated and there will be lot of vibration. So the main factor is lot of heat generated. To avoid that, if there is too much of heat generated, the component may also fail and there will be lot of built up edges of the chips, everything. So in order to avoid all those things, we should use a cutting fluid as a coolant which reduces the heat of the cutting machining process and it maintains the temperature. So cutting fluid cools the workpiece and tool by carrying away the heat generated during machining. So the main purpose of this cutting fluid is to remove the heat generated during the machining process. It also acts as a lubricant at the friction zones. Hence tool life increases as friction gets reduced. The forces and the electricity power consumption decreases. Using cutting fluid produces better surface finish at the workpieces. So there are many uses in using this cutting fluid. It removes the heat, it gives a better surface finish for the workpiece, and it also reduces the force and the electricity consumption. So there are a lot of advantages in using this cutting fluids. Now let us see various functions of a cutting fluid. So cutting fluid, it cools the workpiece and tool by carrying away the heat generator. So this is a very important function of a cutting tool. It removes the heat and giving a better surface finish. So it acts as a lubricant at the friction zones. So in the tool wear we saw, because of the friction between the tool and the workpiece, many wear occurs, like crater wear, flank wear, everything it occurs, which results in damaging the tool, and it also decreases the life of the tool. So the cost is increased and it becomes a burden for everyone. So this cutting fluid, it acts as a lubricant between the friction zones. So in the zones where the friction occurs, if you are preventing those zones, then there will be no wear, which can increase the tool life and the cost of the product can be reduced. As the friction get reduced, the forces and the electricity consumption is reduced. Using cutting fluid produces a better surface finish to the workpiece. It causes the break chip into small pieces. It washes away the chip from the tool. It prevents the corrosion of chips and machine. Improves the dimensional accuracy and control on the workpiece. It permits a maximum cutting speed, hence time for machining is reduced and the cost of manufacturing increases. So these are various functions of a cutting fluid. So the next one is, what are the properties that should be possessed by a cutting fluid? What are the properties so that we can tell this is the best cutting fluid? So it should have a low viscosity to permit free flow of the liquid. So if the cutting fluid is highly viscous, it will not flow freely on the surface. So it should be of a low viscosity so that there will be of a free flow of the liquid, and it should possess good lubricating properties to avoid the friction. It should have a high specific heat, high heat conductivity and high heat transfer coefficient, because the ultimate aim of the cutting fluid is to reduce the heat generated. And the next one is, it should be non-corrosive to work on machine. So if it is a corrosive, it reacts chemically on the surface of the workpiece and the tool and makes it a poor component, or it should be sent to scrap only. So it should be non-toxic for an operating person, and it should be orderless. So if there is a high order, it will not be suitable for machining. So the person who was doing the machining may feel uncomfortable and it may lead to many allergic diseases. So it should be stable in use and storage. It should be safe. It should not be like a acid kind, and it should be permit clear view of the work of the operation. So it should be transparent so that the operator can see what the machining is taking place. So if it is of a very dark one, we cannot see of what's going on in the between the tool and the workpiece. So these are some of the properties that a cutting fluid should possess. The next one is type of cutting fluids. So the type of cutting fluid, it is majorly classified of two types. One is oil based fluids and the other one is chemical based fluids. So oil based fluids, it is of two types. One is straight oils, the other one is soluble oils, and the next one is chemical based fluids. So it is also of two types. One is semi synthetic fluids, the other one is synthetic fluids. So now let's have a brief discussion about what is oil based cutting fluids. So oil based cutting fluids, it consists of diverse range of oil mixtures with various additives and compounds to give the required property of a cutting fluid. So all the fluids, it is not that it directly can be used as a lubricant or a cutting fluid. So some additives, some extra components to be added with the oil, so that it can act as a good cutting fluid and a lubricating oil. So there are of two types. One is straight oil, the other one is soluble oil. Now first let's look into what is straight oils. They are also called as neat oils as they don't contain water. It contains of 100% petroleum oil or mineral oil along with some lubricants such as fats, esters, vegetable oil, as well as extreme pressure additives. So the extreme pressure additive is the one major component which is added with all the cutting fluids to make it work better. So additives are needed for a heavy machining operation. Extreme pressure additives such as sulfur, chlorine or phosphorus compounds are often used as an additive to make the cutting fluid a better performing one. These additives, it improve the lubricating and wettability property. So this extreme pressure additives, it is used in almost all type of the cutting fluids. So if we look into the advantages of the straight oils, they have an excellent lubricating property, tool life can be increased, easy maintenance, no bacterial and odor problems, and the disadvantages are the cost is very high and poor heat dissipating property. So it doesn't absorb all the heat, it has a very poor heat dissipating property and increased fire risk. And applications are, it is used in grinding, tapping, broaching, and for cutting materials like stainless steel, etc. So this is about straight oils. The next one is soluble oil and emulsifiable oil such as mineral oil containing sulfonated oil or soap as an emulsifier for use in the form of an aqueous emulsion as a cutting fluid, textile lubricant, and for carrier for insecticide. So the purpose of this soluble oil, it is majorly used as a cutting fluid or a textile lubricant and also used for the insecticides. So the advantages are, it has a good lubricating properties, suitable for medium and light duty work, it is least expensive. And the disadvantages are maintenance cost. The purchase cost is less but the maintenance cost is high. It is not suitable for stainless steel and the presence of water initiates bacterial growth. So applications, it is suitable for low and medium tensile steels. It is not suitable for stainless steel but it is suitable for tensile steels. So the next one is chemical cutting fluids. So chemical cutting fluid, it contains little or no oil with emulsion and extreme pressure additives. So we saw in oil type, extreme pressure additives are nothing but the phosphorus, sulfur, etc. So they are widely used in industries. They include synthetic and semi-synthetic oils. And the next one is about synthetic oils. So they are water-based fluids and contain no mineral oil. So usually chemical cutting fluids, they doesn't contain any oil. They have a typical particulate size of a 0.003 mm. Water provides excellent cooling properties but creates the problem of corrosion. Also, it is not effective lubricant. So to prevent such rust formation or a rust inhibitors are added. And the advantages of this synthetic oils are, it has a good corrosion control, superior cooling properties, easy maintenance, can be for long periods of time. Disadvantages of a synthetic oils are they have a tendency to foam, and if a foam is created, then we cannot see what are the machining happening, and it will be difficult for the operator to do the machining operation. So this is a major disadvantage. The lubricating property is not satisfactory. If it is a very good lubricant, it prevents the friction between the workpiece and the tool. So if it is not possessing a good lubricating property, that is not much suitable for doing the machining operations, and it can be easily contaminated, it can be easily spoiled. So the applications are it used in carbide tools with diamond wheels, in some CNC machine where stock removal is low. It is not used for a high stock removal process, but it can be used only for a very low stock removal. And the next one is semi-synthetic oil. They are a mixture of soluble oils and synthetic fluid, that is emulsions and water-based fluids. About 5 to 20% of mineral oil is emulsified with water to produce micro emulsion. The particle size, it varies from 0.01 to 0.1 mm. This is small enough to transmit all incident light. This type of fluids are largely used due to their advantage of both soluble oil and synthetics. So if we look into the advantages of a semi-synthetic oil, they are a rapid heat dissipation, cleanliness of the system, bioresistance due to small particle size, and disadvantages are easily foamable. So if it creates the foam, we know that it is not suitable for a machining operation, and lubricating property is not satisfactory. It is satisfactory only, it is not up to very good. And the next one is water hardness. It affects the stability of a semi-synthetic oil. So applications are it is used in general machining operations, grinding where high surface finishes required. So when we compare both the oil type and the chemical type, oil type cutting fluids appears to be better than that of a chemical cutting fluids, as the chemical cutting fluids can easily create some foam, which is not good for a machining operation. So the next one is selection of cutting fluids, the cost and the life expectancy, fluid compatibility with work materials and machine components, speed, feed and depth of cutting operation, type, hardness and microstructure of metal being machined, ease of fluid maintenance and quality control, ability to separate fluid from the work and cuttings, the product's applicable temperature operating range, optimal concentration and pH ranges, storage practices, and ease of fluid recycling or disposal. So these are some of the factors that are to be considered while selecting a cutting fluid for a particular operation, machining operation. So the next one is methods of applying cutting fluid. One is flood application of fluid, jet application of fluid, and spray application of fluid. So these are the three different types of applying the cutting fluid to the machining. So the first one is flood application of fluid. So it is delivered to the cutting zone by means of a pipe or a hose or a nozzle system. And the second one is jet application of fluid. It is directed to the directly of a cutting zone. And the third one is spray of a this is by automized by jet of air, and a mist is directly directed to the cutting zone. So these are the three methods of applying cutting fluid. So this is about the cutting fluids in a machining operation. Thank you.